Hi guys, it's Professor Graywood here. Today we're going to talk about maps, and more specifically we're going to give you a refresher in latitude and longitude. I bet you haven't really revisited that concept since middle school, so your memories might be a little hazy. Your textbook is great, but it really doesn't do a terribly good job at addressing this particular topic, hence the need for a video. Alright, so let's talk about maps. Maps are always a simplified version of reality that we're using to record information about the Earth's surface. Any cartographer, that is a person who is invested in the science of map making, is going to be filtering out what they put on a map and what they don't put on a map. That means that maps themselves are always going to be distorted, not only because of what they represent on their map and don't represent on their map, but also because you're really looking at a two-dimensional representation of a three-dimensional reality, right? The globe is 3 dimensions, and yet what we're creating is put on paper, and it's only 2 dimensions. So just be aware that there's always bias in every map that you look at. But we're getting a little further afield from where I wanted to go. Let's talk about grid systems. When we start looking at how we actually describe a point on a map, that's actually kind of difficult if you think about it. Imagine, if you will, that I was tossing you a ping pong ball with a dot marked on it. You'd probably struggle to describe that dot's location, right? So portraying a point on a map in a universal way is something that cartographers have struggled with for a long time. But no matter what culture we look at, essentially what it comes down to is they create a grid system like the one that you see here. So a grid system is one that has 2 axes, a vertical axis and a horizontal axis, just like you see here. And you have to establish meaningful nomenclature for this axis. In the case of our image that you see here, we've got a red dot, and we can all agree that the dot lies at B4 and understand that. And even if our dot doesn't lie at a perfect point at the intersection of these axes, we can still figure it out. We could say E.5 and 5.5 and know that we were talking about the yellow dot, right? When we talk about grid systems, latitude and longitude is just another example of a grid system. So let's think about applying this system to the Earth. As I said, the Earth is a 3-dimensional object, right? Not only is it a 3-dimensional object, but it's not quite a sphere. It's actually an oblate, as you see depicted here. So an oblate is a sphere that is slightly squashed, if you will. Imagine a basketball that someone sat on and you have an oblate. And thanks to those lovely Greeks, we know that a circle is defined as 360 degrees. So when we look at the globe, we can divide it up into 360 equal points. And within a single degree, we have 60 minutes. And within a single minute, we have 60 seconds. Taking that a step further, that means there are 21,600 minutes on the globe. We arrive at that number by multiplying 360 degrees by 60 minutes. Taking that a step further, we can also say there are 1,296,000 seconds on the globe. We arrive at that number by multiplying those 21,600 minutes by a further 60 seconds. Still with me, folks? All right. Let's look at our 2 axes applied to a map. So here we've just taken our map, we've flattened it. This is, of course, a flattened projection of a 3-dimensional surface. What I'd like you to note here is that our vertical axes no longer meet at a single point here, right? Now they're all equidistant apart. But this works for us. This is, a system of latitude and longitude. You can see that we can apply, any sort of nomenclature we want here. You'll note that this particular graphic shows both letters to show nomenclature, or it applies actual numbers to show nomenclature. Let's talk about our vertical and our horizontal axis. When we talk about our vertical and our horizontal axis, we're really talking about the two hemispheres of the Earth. Hemi stands for half. So if you will imagine we had a giant knife in space and we divided the Earth in half, either north to south or east to west, what we would come up with then are our hemispheres. So these dividing points, these dividing lines, then become our 0 points for our axis, right? If we divide the Earth in half into a north and a south hemisphere, the 0 point for these two hemispheres is the equator. If we divide the Earth in half into an east and a west hemisphere, the 0 point for our axis becomes the prime meridian on one side of the Earth, and on the other side of the Earth, dotted in there for you, is the international dateline. These become the 0 points in our axis for longitude and latitude. So let's talk about latitude a little further. Latitude lines run east to west. They're also known as parallels. We call them parallels because they never intersect each other. You'll note, of course, as we just discussed in our topic of hemispheres, that the equator is the dividing line. So we have latitude lines that run either north or south of the equator. And you must always be certain to designate when you write latitude whether it is north or south of the equator. If you don't, it really could be any one of 2 points on the Earth's surface. Now the other thing to note about latitude is that the poles are also the terminus for latitude. That means then that you are ascribing 1/4 of a circle when you look at latitude. That means that you can cover no more than 1/4 of a 360-degree circle, which means latitude never exceeds more than 90 degrees. If you're having trouble remembering the difference between latitude and longitude, remember that with latitude, you're always climbing up or down the rungs of a ladder, which sounds to me a lot like latitude. I've also had students that tell me latitude is kind of similar to fatitude, and latitude lines are always fat, whereas our longitude lines intersect, and so they become more thin. Let me show you what I mean. Longitude lines, you'll note, all intersect at the north and the south poles. So they're not parallel. Instead, the distance between the lines decreases as we approach the poles. It is at its widest point at the equator. So these lines run north and south. They're all written as east or west of the prime meridian. And now in some places, I do want to caution you, you'll see the prime meridian written as the Greenwich meridian. And the reason it's written sometimes as the Greenwich meridian is that in 1884, Greenwich, England was established as the point of the prime meridian. So all lines of longitude are labeled as east or west of this line. And again, remember that you'll want to always state whether a point of longitude is east or west of the prime meridian, because otherwise it could be one of 2 points on the Earth's surface. Now, with longitude, you are covering half of a circle. That means that longitude can go from 0 to 180 degrees, but no more than 180 degrees. A few final thoughts for you when you are recording latitude and longitude. Remember, there's always 1 degree equaling 60 minutes, and within 1 minute, there are always 60 seconds. So half of a degree would then be 60 minutes. 1/4 of a minute is going to be equal to 15 seconds, right? You'll want to be able to do those sort of calculations. Remember, we always write the horizontal portion of our axis first, and then the vertical portion of our axis. That means we always write latitude first, and then longitude second. Remember, your latitude can never be written as higher than 90 degrees, and never east or west. It always must be written as north or south of the equator. And your longitude should never exceed 180 degrees. And it should never be written as north or south, because north or south is going to be the same longitude anywhere on that point. Instead, we always note whether it is east or west of the prime meridian. Alright guys, hopefully now you feel slightly better equipped to go out and begin calculating latitude and longitude on your own. I would encourage you to go ahead and try out the short interactive exercise we have on latitude and longitude. Again, it's a little touchy to use, but it gives you a chance to actually begin putting some of these skills into practice. Have a great day.